Hey everyone, we're going to take a look at the homework problems that are due on Friday. So we'll start with number 21, and it asks us to determine whether the two lines are parallel, skew, or intersecting. If they intersect, find the point of intersection. So here's the two lines. X minus 2 over 1 equals y minus 3 over negative 2. Sorry, that's a 3. Equals z minus 1 over negative 3. And then x minus 3 over 1 equals y plus 4 over 3 equals z minus 2 over negative 7. So parametrically, we'd have this as x equals 2 plus t, y equals 3 minus 2t, and z equals 1, is that a negative 3? Yeah. Minus 3t. So the direction vector is 1, negative 2, negative 3. I'm going to use a different parameter here. I'm going to use the parameter u. So x equals 3 plus u, y equals negative 4 plus 3u, and then z equals 2 minus 7u. So if the two lines are to intersect, they don't have to intersect at the same time, which is why we use a different parameter. It doesn't have to be like t equals 5 or something like that. So they do have to have the same coordinates, though. So 2 plus t needs to equal 3 plus u, and 3 minus 2t needs to equal negative 4 plus 3u. So let's just solve this by substitution. So negative 1 plus t equals u. So 3 minus 2t equals negative 4 plus 3 times negative 1 plus t. Okay, so t would need to equal 2, and u would need to equal 2 plus negative 1, or 1. So let's confirm that that works for each of the coordinates. So when t equals 2, x is 4. When u equals 1, x is 4. When t equals 2, y is negative 1. And when u equals 1, y is negative 1. Now z is going to be the one that will tell us whether or not this is right, because we knew it was right based on solving the system. So when t equals 2, 1 minus 6 is negative 5. And when u equals 1, 2 minus 7 is negative 5. So yes, they do intersect. So the intersection point is 4, negative 1, negative 5. Okay, next is 37. 37 asks us to find the equation of the plane that passes through the point negative 1, 2, 1, and contains the line of intersection of the planes x plus y minus z equals 2 and 2x minus y plus 3z equals 1. Okay, so let's find the line of intersection of those two planes. To do that, I'm going to take the cross product of the two normal vectors. So normal vector 1 is 1, 1, negative 1, and normal vector 2 is 2, negative 1, 3. So for our I component, I have 3 minus 1. For our j component, I have 3 plus 2. And for our k component, I've got negative 1 minus 2. So my vector is 2, negative 5, negative 3. This is my direction vector v for my line of intersection. We also could use a point that's on that line of intersection. So I'm going to do that by letting z be 0, giving me x plus y equals 2, and 2x minus y equals 1. Adding down gets us 3x equals 3, or x equals 1. And then resubstituting, we have y equals 1 as well. So a point on the line is 1, 1, 0, which means parametrically, my line of intersection is x equals 1 plus 2t, y equals 1 minus 5t, and z equals negative 3t. Okay, let's take now 3 points on our new plane. So we have 2 of them. Here's a given point. Here's a point that we just determined, and now let's let t equal 1. So a new point would be 3, -4, and -3. So we've got 3 points that lie on our plane. With those 3 points, we can create 2 vectors and then find the normal vector for our plane that way. All right, so vector 1, which is parallel to the plane. I'm going to take 1, 1, 0 minus -1, 2, 1. So I've got 2, -1, -1. And then for v, I'm going to take my point 3, -4, -3, and subtract -1, 2, 1. So I've got 4, -6, and -4. Those 2 vectors lie parallel to the plane. I'm going to take the cross product of those 2 vectors now. This would be 4 minus 6. This would be -8 plus 4. And -12 plus 4. Okay, so we have -2, -4, so 4, and then that's going to be -8. Okay, I'm gonna leave it as is there. You could, because we're only interested in the direction of that vector, not its magnitude, you could divide through by, say, -2 or something and make it a little bit easier. I'm not going to do that. So here's our plane. It's going to be -2 times x minus 1. I'm getting that 1 from up here. Plus 4 times y minus 1. And then minus 8z equals 0. That is the equation of our plane. Now, we could go confirm that. That might be fun to do just for this one. Let's try that. If you want to skip this in the video, that's totally up to you. All right. So here is CalcPlot 3D. And I'm going to plot the 2 original planes using implicit surface. So I'm going to go x plus y minus z equals 2. There's that plane. And then I'm going to do the second plane as 2x minus y plus 3z equals 1. There's the second plane. So we're going to need our new plane to go through the line of intersection of those 2 planes. Okay. So our plane was -2 times x minus 1. It's 4 times y minus 1 minus 8z equals 0. Did it. It goes through the point of the line of intersection. Let's also make sure that it contains the given point. So I'm going to plot the point that was given, and it was -1, 2, 1. Let's confirm that it's on that plane. There it is. It's on the plane that we devised. Okay, we did it. So that's confirmation that we did it right. All right, next problem is 62. All right, 62. Find an equation for the plane consisting of all points that are equidistant from the points 2, 5, 5 and -6, 3, 1. All right, so the plane consists of all points x, y, z, and we know that that point has got to be equidistant from both of those. So the square root of x minus 2 squared plus y minus 5 squared plus z minus 5 squared equals the square root of x plus 6 squared plus y minus 3 squared plus z minus 1 squared. Okay, well, we can square both sides, obviously, and then we can clean this up to be... I'm just going to do the algebra here, so I'm not going to talk through everything in detail. All right, clean this up and we'll have it. So subtract x squared from both sides, subtract y squared from both sides, same for z squared. Pull this combined with this, so that's -16x Let's do negative 10y. Combine it with this. That's going to be minus 4y. Let's do, where's my z? Negative 10z. It's going to be minus 12z. Now let's do the numbers. So 4 plus 25 is 29. So we got 54 here. 54 minus 36 is 18. Minus 9. Oh, shoot. Yeah, that's okay. Minus 9 is 9. Plus 1 is 10. I think it would be then equal to negative 10. I think I got that right. If I messed up the algebra, whatever. You get the idea. Okay. All right. Might have messed up the mental math. 74. Okay, 74 says, find the distance between the given parallel planes. All right, cool. So we have a formula for this. We just have to set up the plane equation so that we can use it. So there's the first plane equation. So they're given to us in kind of an odd form here. So let's use this one. That it's the absolute value of the d values, the difference of the d values, and then a squared plus b squared plus c squared. All right. So my first plane I'm going to write as 2x minus 4y plus 6z equals 0. I'm going to divide through by 2, so x minus 2y plus 3z equals 0. There's my first plane. And then my other one is going to be 3x minus 6y plus 9z minus 1 equals 0. Okay. I'm going to divide through by 3 to get x minus 2y plus 3z minus 1/3 equals 0. So our d values are 0 and negative 1/3. The difference between those is 1/3. So my distance is 1/3 over the square root of 1 plus 4 plus 9, or 1 over 3 root 14. Okay. Good deal there. And then the last one is 79. Let's confirm our answer on 74 real quick. Let me just look it up. Okay. This was from section 12.5. Number 74. 1 over 3 root 14. Is that what I got? That's what I got. Cool. Okay, and 79. Let L1 be the line through the origin and the point 2, 0, negative 1. So L1 contains the origin and the point 2, 0, negative 1. And L2 contains 1, negative 1, 1, and 4, 1, 3. Find the distance between L1 and L2. Okay, so this is just like what we did in class. So we're going to kind of follow through that process. So direction vector number 1 is 2, 0, negative 1. And direction vector number 2 is 3, 2, 2. Crossing those gives us the normal vector for a plane that we're going to construct containing one of the lines. Okay, so we'll say n equals v1 cross v2. Okay, so we got 0 minus negative 2 or 2, and then 4 plus 3 or 7, and 4. Okay, so this is 2, negative 7, 4. Now let's construct a plane that contains L1. So that's easy because we've got a point that's the origin. So 2x minus 7y plus 4z equals 0. So this plane contains L1 and is parallel to L2. So if we pick a point on L2, which we have, let's use the point 1, negative 1, 1, we can now use point to plane formula to do it. Okay, so here it is. The a value, 2 times x1 is 1. The b value, -7, times x, or y1 is -1. The c value, 4, times the z1, which is 1, and then plus d, which is 0, all over the square root of 4 plus 49 plus 16. Numerator is 2 plus 7, 9 plus 4 is 13. Denominator is 49 plus 16, which is 65, plus 4, root 69. So 13 over root 69 is my answer. Let's confirm that. 13 over root 69. Oh, we did it. Great. Okay, that's everything. Hopefully that was helpful.